Well, hello students. In the previous class, we had all the concept regarding the starting of capacitance. So in this class, we shall be learning about capacitance. Okay, it is a new concept of electrostatics. Our electrostatics is not over yet. Let us finish capacitance. It is a very good concept. You are going to enjoy it. Okay, so let us just start capacitance. So let me write capacitance. We are going to learn the concept behind capacitance, and then let me see. Yes, it is visible. Okay, so you are quite similar to this word. Okay, you are quite similar to this word, not this word exactly, but this word. You are quite similar to this word, capacity. Okay, capacity. So if I consider a tumbler, okay, simply a glass, simply a glass. So its volume, or you can say its capacity, let it be 500 ml. Okay, let we can fill the glass up to 500 ml of water or any liquid thing. It is its capacity. The capacity of this glass is 500 ml or the volume. Now it is full to the brink. Okay, it is full to the brink. Now if you are going to add even an ml, you just are going to add an ml of water more, it is 1 ml. So when you add to this glass, you will see that the water starts to overflow. The water starts to overflow from this glass. Okay. Now in that against case, you just consider a bucket. You can also consider a glass, no worry. This is a bucket, but the base is open. But the base is open. Okay. Now you are pouring water. When the base was closed, let the capacity was 10 liter. Okay. When it was a uniform bucket, a good bucket, so you could fill 10 liters of water up to the when it becomes full. Now what you did, you just took out the base of the bucket. Now you start pouring in water. You will see that you can actually fill inside the bucket an infinite amount of water. Infinite amount of water. Okay. So the concept of capacity becomes invalid in this case. It is valid in this case, but in our daily life problem, it becomes invalid in this case. Okay. So it is the same thing when we consider a conductor. Now, when we this is a conductor, let this be a piece of conductor. We are giving charge to the conductor. Okay, we are giving charge to the conductor, or we are charging the conductor. This is Q, this is Q, this is Q, this is Q. They may be same or different. No need to worry about that. This Q may be same or different. No need to worry about that. So first of all, you just consider that you sent this charge Q to it. That means the conductor becomes charged. Now, when it has a charge, that means the potential of the conductor rises. Now, what you did, another charge is pushed to this point. A charge was already at this point, another charge is pushed to this point. That means the charge, they build a system of charges, and you know that the potential rises when system of charges or the number of charges in a system increases. Okay, now you are just giving it charges, it charges, this charges, just like this. It is able to hold 500 ml of water, and even after that, when you add 1 ml of water, the glass just overflows. Likewise, this is the same case in a conductor. You are adding charges which raises the potential of the conductor high and high and high, and up to some point. Okay, Up to some point, it has stored a large number of charges. It has actually stored a large number of charges, and up to some point, it will not be able to hold those charges together on that conductor. It won't be able to hold those charges together in that conductor. Okay. So what will it do? It will start to leak out. It will start to leak out. At that point, it will start to leak out, just like in this case when the water started to overflow. In this case also, charge will also overflow from that conductor. Okay. So that is the capacity of that conductor up to some point. Okay, the capacity of holding charges to this concept. When we relate this concept, the glass had a capacity of 500 ml. That means it is able to hold 500 ml of some liquid, of any liquid. Likewise, if you compare this case to this case, you will see that the conductor is also able to hold charges, just like the glass is able to hold the water. So, and also you can compare at this point when the glass is already full and you try to add some more liquid to it, and it is the same case in case of conductor. When the conductor is no more able to hold charges, it will start to leak out, like the water is getting overflowed from the glass. Okay, so let us just, I hope that you have understood the concept of capacitance. So we are going to come to the definition. So what just happens when you add charges? When you add charges to a conductor, when you add charges to a conductor, when you are adding charges to a conductor continuously, you will see that its potential rises. The potential of that conductor rises. So we can see that whenever the amount of charge is increasing, we can see that the potential also increases. That means it should have a relationship between Q and V. There should be a relationship between Q and V. So it has been observed that whenever Q increases, V increases. That means Q is directly proportional to V. Okay, Q is directly proportional to V, or charge is directly proportional to that potential. Now, in order to remove this proportionality, we need to introduce a proportionality constant. That means Q is equal to constant, this is a constant, times V. This is a constant times V. So Q is equal to, this constant is C. This constant is C. Okay, so what is C? So C is equal to Q by V, and this C is called the capacitance of the conductor. This C is called capacitance of the conductor. So this C is called the capacitance of the conductor. So it is a constant for a given material. Okay, it is a constant, not for a given material, for a given shape of it, or for a given conductor. C depends upon the shape of that conductor. It depends where another conductor is at the neighborhood of our concerned conductor. It depends upon some factors. Those factors are not necessary to mention here. So I already mentioned that somehow C depends upon, or it is dependent upon the shape of that conductor. Okay, this is our necessary thing. So let us just, we will just write the definition of that capacitance. So what is capacitance? Capacitance is C is equal to Q upon V. So let us just convert these things into statements. I hope that you have understood the concept. So let us just convert these things into statements. We are going to write these same things in very short sentences. Okay. So what have we observed? We observed that whenever a conductor is given a charge, its potential increases. Its potential increases. You can write like this. So you already know that Q is directly proportional to V, and Q is equal to constant times V. In order to remove that constant or proportionality thing, you need to introduce a constant, and this constant in this case is the capacitance of the conductor. This constant C is called capacitance. Capacitance of the conductor. Okay, C is called capacitance of the conductor. So C is equal to, you can write Q upon V. So what should be the definition of C? What should be the definition of C? So capacitance of a conductor, you can write capacitance of a conductor is defined as the ratio between the charge, okay, defined as the ratio between the charge it holds and its potential. So simply you are just writing this thing, the formula, into a definition. So what is capacitance of a conductor? It is defined, simply defined as the ratio between the charge it holds and its potential. Okay, and its unit in SI unit, it is farad. Okay, it is farad. It is, you are going to write capital F or FARAD. Okay, you are going to write like this, F or farad. It is a very large quantity. Okay, 1 farad of capacitance is a very large quantity. How is this a very large quantity? You will get to know after we have finished some concept. After, when I finish this thing, I will go to that concept. Okay, so the SI unit of capacitance is farad. It is written as capital F, or simply write like this, FARAD, farad. Okay, so we have concluded the SI unit of capacitance. You can also write the capacitance, the SI unit of capacitance as, you see, farad is equal to 1 farad. From the definition, 1 farad is equal to, this should be unit, this should be unit in order to consider this unit, or 1 farad. So 1 coulomb, 1 coulomb upon 1 volt. Okay, this is the definition of 1 farad. You can write it as the definition of 1 farad. So we will write the definition of 1 farad to the left side of this thing, and then we will rub up these things and we'll try. So the unit is farad. You can also write unit is coulomb per volt. Don't get confused with these things. Okay, it can be given, the capacitance, the unit of capacitance can be given, or in any numerical. If you find that it is given as coulomb per volt, you have to recognize it as the capacitance given. Okay, don't get confused between farad and coulomb per volt. They are the same thing. Okay, so let us just continue this. We will try to define 1 farad. What is 1 farad? You can see that 1 farad is the amount of capacitance, or the capacitance of a conductor is called 1 farad when 1 coulomb of charges are added to that conductor in order to raise the potential to 1 volt. Okay, so you can write like this. So I think I am going to rub these things off. So let us just write the definition of 1 farad. So what is 1 farad? The Capacitance, you can write the capacitance of a conductor. You can write the capacitance of a conductor is 1 farad when 1 coulomb charge is added to the conductor to raise its potential to 1 volt. To raise its potential to 1 volt. Okay. So this is your definition of 1 farad. You can actually note this, but it is not necessary. You can actually just remember it from here. So SI unit is, so you can write SI unit is farad or coulomb per volt. These are the things you can actually note. And now we shall be going to calculate the dimensions of capacitance. Okay, we shall be calculating the dimensions of capacitance. So I think you can actually calculate the dimension of capacitance since Q is equal to Q by B. From your point of view, you can actually do it. So how are you going to do it? The dimensions of capacitance. You know the dimensions of charge. You know the dimensions of potential difference or potential, and you have to calculate the dimensions of capacitance. So you have to proceed like this. So I see that this thing is just blurring out it. So I write it like this. Okay, at this point it is bold. Yes, it is visible now. So now you have to calculate the dimensions. As just consider that you don't know the dimensions of what, or you don't remember it. You can actually calculate it from here. How? You know that B is equal to joule or W by Q. Okay, you know that. Okay, W is the work done, Q is the charge. You can write W here, Q here. Now it becomes Q square by W. That means W is the work done, this is the charge. The work done is the energy. Okay, you know it quite well. So what are the dimensions of Q? A1 T1, since it is squared, divided by energy. I hope that you remember the dimensions of energy. What are those? It is M1 L2 T raised to the power minus 2. Okay, so you need to remember the dimensions of energy. Okay, just calculate the dimensions. A2 T2 divided by M1 L2 T to the power minus 2, and here you can actually see that M to the power minus 1 L to the power minus 2 T to the power 4 and A to the power 2. So when you are asked about the dimensions of capacitance, you will be writing this or you will be deriving this. Okay, at last. Now it has been asked in some exams, they write out the dimensions of capacitance in terms of mass, length, time and current. You have to put focus in this thing. Okay, if the examiner asked that write the dimensions of capacitance in terms of mass, length, time and current, you should write -1 comma -2 comma 4 and 2 are the dimensions of capacitance in terms of mass, length, time and current. Now if the examiner asked you that find out or give the dimensions of capacitance in terms of mass, time, then length, then current, so these things get reversed. Okay, you have to be careful while writing the dimensions in terms of their order. Okay, so we have finally finished the capacitance. Not we didn't finish the concept of total capacitance. We have just finished capacitance, and another term is elastance. Another term is elastance. You should get yourself familiar with this term. So there is a power cut. So we'll continue with the emergency lights what we have. So you should get yourself familiar with another term, that is elastance. Okay, it is elastance. It is denoted by E or anything else. Okay, it is just the reciprocal of capacitance. It is just the reciprocal of capacitance. E is equal to 1 upon C. What will be the capacitance? The reciprocal of capacitance is equal to the elastance of that conductor. Okay, so by definition, you will write it is defined. It is defined as the reciprocal. It is defined as the reciprocal of capacitance. It is defined as the reciprocal of capacitance. I hope that it is visible to you. Yes, it is totally visible. So elastance is defined as the reciprocal of capacitance. So the unit shall be the reciprocal of the unit of capacitance. So the unit is farad inverse. Okay, you can write F and introduce -1 on its power, farad inverse or farad inverse. Okay, this is the unit of elastance, and also the dimensions of elastance are the, you can write like this, the dimensions are actually opposite or reciprocal of capacitance. So M1 L2 T to the power -4 and A to the power -2. These are the dimensions of elastance. Okay, this is the dimensions of elastance. Let me take it to the different low. So these are the dimensions of elastance. So due to power outage, we can't be continuing further. So we shall see you in the next class, where we shall be learning some more concept in capacitance. So up until then, and one more thing, in this concept, we shall be using the term capacitor. Okay, we shall be using the term capacitor in case of this conductor. Okay, whatever be the holding capacity of an object, we are going to turn those objects as capacitor. Okay, and after that we shall be learning some, or the concept behind a capacitor, or how does it work. We shall be knowing that a capacitor is also known as a condenser. So some more interesting thing will be coming to you in the next class. So I apologize for the power cut. Up until then, take care and practice more.